Hey everybody, Stephanie Brewer here from Kids First Education coming at you with another Math in a Minute. Today we're going to look at converting metrics. This standard runs across both fourth grade and fifth grade. If you look here, for fourth grade, within a single system of measurement, going from a larger unit to a smaller unit. However, in fifth grade, you can go not only from a larger to a smaller, but also from a smaller to a larger, and also real world problems and multi-step equations. So let's look and go from there. So let's talk about multiplying by 10 because that's how the metric system works. If we start with the number 1, what happens when we do 1 times 10? You're right, it's 10. 1 times 100, which is 2 tens, 10 times 10, that's 100. And 1 times 1,000 is 1,000. Well, if you notice, the decimal is understood to be right here. It's kind of invisible. You can see where my pointer is. Did you notice that as the place value change, the decimal appears to move, but it doesn't really. It's the place value that changes. Can you see that? Times 100 times 1,000. Well, let's look at it again, but this time let's look at division. 1 divided by 10 is 1/10. You can see that the place value shifted. Again, let's go divide by 100, which is 1/100. It shifted 2 places. And 1 divided by 1,000 is 1/1,000, which means it shifted 3 places. All right, let's look at one more example, but this time we're going to use the number 52. Let's just start with 52. We're going to go to the right first. So 52 times 10, what do you think it'll be? You're right, 520. 52 times 100, 2 places to the right. Again, 1, 2. And 52 times 1,000 is 52,000. All right. Now that's multiplying. Let's divide. 52 divided by 10. What do you think we're going to get? You're right. 5 2/10. Because the place value shifted 1 place. 52 divided by 100. What do you think? You're correct. That would be 52/100. And 52 divided by 1,000 is 52,000. And there you have it. Now we're going to actually use this idea of multiplying by 10 and dividing by 10 to convert metrics. So let's look here. We're going to start the center of this graphic with units. Now our units could be liters, grams, meters. We will use both meters and liters in this presentation. And if you look to the left, we're going to start with the prefix kilo. A kilo is 1,000 times the unit, whatever it is. Hecto is 100 times the unit. Deca is 10 times the unit. Dessa is 1/10 times the unit. Centa is 1/100th times the unit. And milla is 1/1000th times the unit. Now, there's a cute little phrase that some people use to help them remember this order, and here it is. King Henry does usually drink chocolate milk. That's an easy way to remember kilo, hecto, deca, unit, dessa, centa, and milla. Now let's apply this. So I found this really cool graphic that might help you remember when you move to the right, you're multiplying by 10. When you move to the left, you're dividing by 10. If you move from a larger unit to a smaller unit, you're multiplying. If you're going from a smaller unit to a larger unit, you are dividing. Now let's apply. So we're going to do the fourth grade version of this problem first, and then we'll shift to fifth grade. Yesterday, I ran less than 5 kilometers, but more than 1,200 meters. How far could I have run in meters? Well, we're going to end up in meters, so I'm going to need to change 5 kilometers to meters. Well, let's look at our chart and start with 5 kilometers. To move to hecto, what do? You're right, multiply by 10, and 5 times 10 is 50. To move to deca, times 10 again, which is 500. To move to my unit, which is meters, times 10 again, 5,000. So 5 kilometers is equal to 5,000 meters. Now, the problem with a word problem is that you really need to know what the question is. Here it is. How far could I have run in meters? Well, the low end would be 1,200 meters, and the high end would be 5,000 meters. So the answer is between 1,200 and 5,000 meters. You did great. Let's move on to the fifth grade version. Yesterday I ran less than 5 kilometers, but more than 1,200 meters. How far could I have run in kilometers? Oh, so this time the answer needs to end in kilometers. So that means I'm going to need to convert 1,200 meters to kilometers. So that means I'm going to start with the base unit right here, which would be meters. All right. So 1,200 meters. Now I'm going to the left this way. So I'm going to divide by 10. If I take 1,200 divided by 10, I get 120. Divide by 10, I get 12. Divide by 10 again, I get 1 2/10. So 1,200 meters is equal to 1 2/10 kilometers. Now, again, the question is, how far could I have run in kilometers? Well, on the high end, it's 5 kilometers. On the low end, it's 1 2/10 kilometers. So this is between 1 2/10 and 5 kilometers. Great job, everybody. Let's move on to another problem. You can always pause this if you want to think about it a moment. We're going to do the fourth grade version first. Mr. Perkins changed the oil in his car. He bought 6 liters of oil. He put 4,500 milliliters in his car. How many milliliters of oil did he have left? This seems like a multi-step problem. Well, I know that I'm going to have to end in milliliters, so I need to look at this 6 liters right here. So 6 liters equals how many milliliters? I'm going to go here because my base unit is liters. And 6 liters times 10, 60 times 10 again, 600 times 10 again, 6,000. So 6 liters is 6,000 milliliters. Great job. Now the question says he put 4,500 milliliters in his car. So I started with 6,000 and I'm going to use 4,500. So the problem, how many milliliters of oil did he have left? 6,000 milliliters minus 4,500 milliliters is 1,500 milliliters. And let's answer the question, 1,500 milliliters. Great job, everybody. Let's look at the fifth grade version. Mr. Perkins changed the oil in his car. He bought 6 liters of oil. He put 4,500 milliliters in his car. How many liters of oil did he have left? Oh, so I need to take this 4,500 milliliters, which will put me right here, and find out how many liters that is. So we're going to start with 4,500 divided by 10. which will be 450 divided by 10, which will be 45, and divide by 10 one more time to get to the unit of liters. That's 4 5/10. And here we have it, 4 5/10 liters. Again, what's the 6 liters minus 4 5/10 liters equals 1 5/10 liters. We established that we are trying to find out how many liters he had left. 1 5/10 liters, or 1.5 liters, is what he had left. Great job, everybody. This has been Math in a Minute or Two coming at you from Kids First Education. For more Math in a Minute videos, visit our website at www.kidsfirst.llc. Kids first, always.